And we are live on Facebook. Good afternoon, everyone. Welcome to another New Jersey Constitutional Republicans virtual conversation. I'm honored today to have my good friend, Dr. William Happer, join me today. Doctor, welcome.
Thanks very much, JR.
It's certainly an honor to have you join me today, Dr. Happer, and please give our audience a brief bio about yourself to start the program.
Well, thanks, JR. I'm a physicist, and I've spent most of my career in academia, but I also spent some time in Washington as a government bureaucrat. Apologies for that. And I also did a startup company for a few years. So I've done a number of things. My specialties are, atomic and nuclear physics, atmospheric physics. As I'll point out on some of the view graphs we'll use in a few minutes, I'm probably best known for inventing the sodium guide star that all modern big telescopes use, and it's a nice visual. I'll show you some in a minute or two. But anyway, I'm a nuts and bolts physicist.
That's right. And of course, you worked under the George H.W. Bush administration. You currently, or contemporarily, you were working for President Trump as his administration. So you certainly have a great pedigree and a tremendous amount of experience. And what we're going to talk about today is, of course, a very, very important issue, and that is climate change. And I wanted to start the program by asking you, essentially, Doctor, what the difference between what we call anthropogenic global warming as opposed to climate change. What is the difference?
Well, that's a good question, JR. The fundamental difference is that the amount of warming that humans can cause is not very big compared to natural warming. It's really quite small. You can see it around big cities. Cities are typically a degree or two warmer. That's called the urban heat island effect. And it's because, you cut down all the trees and that you don't get transpiration cooling, but you practically see no warming in the countryside. And that's expected from the basic physics too.
Now, Doctor, you've been kind enough to put together a presentation for our program today. And if you'd like to begin that, to begin your presentation that you have for us through your share screen.
Okay, well,
and, go ahead.
Let me explain. I gave a talk about a year ago to the vet school at University of Pennsylvania, because one group of people who are suffering from all of the climate fanaticism are the farmers, in America, Ireland, Holland, all across the world, because they're allegedly ruining the climate by letting their cows chew their cud and, burp and do the things that cows always do. That's complete nonsense. But anyway, that's the origin of these presentations. So let me see if I can bring it up here. So here's share screen, and
while you're bringing them up, Doctor, I wanted to mention the fact that growing up in the 70s, we remember the fanaticism in relation to the ozone and how we couldn't use aerosol cans, and this was an existential threat at the time. And of course, all of that died down. And of course, in the 80s, we had all of the fashionable, the ladies were using the aerosol cans to bush up their hair and bring out their hair. And of course, all the rock bands were using the aerosol cans to get their hair to be more and more duller and bigger. So the ozone was a big issue in the 70s, and we don't hear anything about that anymore. And there was a tremendous amount of alarm dedicated to that, correct?
Yeah, that's right. And really had very little scientific basis also, but it didn't matter nearly as much as the climate alarm, because it did cause some unnecessary expenditures, replacing really good refrigerants, freons, with things that were not so good, and that continues. It's corrupt, it's a way for companies to, force people to buy new refrigerants when the old ones go off patent protection. And so,
Mhm.
there's,
Fascinating.
there's a lot that is not what you think it is in the environmental protection. But
Well,
anyway, if
our
it's okay, I'll
conversation,
say a few words here. So let me go through and stop me at any point. We'll chat. Okay.
great.
So let me see if I can get this thing
Looking,
to advance. So
here we
the uh,
go.
so the excitement over climate change is because of these greenhouse gases, and the major ones are carbon dioxide. Carbon dioxide is three atoms stuck together, two oxygens on the end and a carbon in the middle. It's a
Mhm.
straight line. It's a linear molecule. Uh, by far the most important, however, is water vapor, which is
Mhm.
everywhere. It's in our own breaths. It's quite steamy today. If you go outside, there's a lot of vapor in the air. The clouds are full of water vapor. It's also three atoms stuck together, two hydrogens and a oxygen in the middle, but it's bent, unlike carbon dioxide. That has some
Mhm.
consequences for the way it behaves.
Hmm.
Then there's methane, which is used to demonize farmers. You can't grow cows without the cows chewing their cud and, burping methane from time to time. They've been
Mhm.
doing that, since the earth was founded.
Mhm.
That's, Abraham's cattle burp methane too, and they're not going to stop. Uh, and the deer and the buffaloes, so it's really absurd. And finally, there's nitrous oxide, which is a byproduct of fertilizer, and it's also a greenhouse gas, comparable to nitrogen, methane.
Mhm.
Methane and nitrous oxides are very minor greenhouse gases. The major one is water vapor. Carbon dioxide is sort of in between. It's minor compared to water vapor, but a lot more important than nitrous oxide or methane. So that's what all the
Doctor,
excitement is about.
doctor,
Yeah.
can you explain to us what the term greenhouse means? Why is that the vocabulary so predominant in this discussion?
Yeah. Yeah. We'll say some more about that, but I think you
Okay.
know that, if you want to protect your plants in the early spring from frost, or perhaps even the whole winter, you can put them inside of a greenhouse with, you know, panes of glass over the roof. So sunlight can come in through the panes of glass so the plants can get the sunlight they need to grow. But it's
Mhm.
hard to get the heat out. Uh,
Mhm.
Greenhouses on Earth, most of the protection comes from the prevention of convection. The warm air in the greenhouse that's warmed by the sun is not able to rise through the roof of the greenhouse. And so that's the main
Mhm.
effect. It has, people sometimes think it's due to infrared radiation not getting through the glass. It's true, infrared won't go through glass, but that's not the main way a greenhouse works. But anyway, that's
Mhm.
the basic idea, that these gases in our atmosphere behave a little bit like the panes of glass in a greenhouse, and prevent the heat from getting back to space that has come in from the sun. We're warmed by the sun,
Mhm.
and unless we get rid
Mhm.
of that heat, the earth would just continue to heat up. And so we get
Mhm.
rid of the heat by the earth glowing in the dark. It radiates infrared radiation into cold space. And so greenhouse
Mhm.
molecules, like an earthly greenhouse, retard that escape of radiation somewhat. Not very much, but enough that it matters. Okay, so let me say,
Fascinating.
if is that okay as an answer for that?
Oh yeah, absolutely. And
Okay,
just
so let's
quickly,
let's see if we.
methane is flammable, is it not, Doctor?
Yeah, that's natural gas. That's what you burn in your stove. And unless you use
Mhm.
propane is two methane stuck together, two or three methane stuck together, I guess. But they're very similar. They're what they call hydrocarbons, and God
Mhm.
bless hydrocarbons. They've done a lot of good for the world. We're,
Yes.
and some bad too. You're fat. If you're overweight, most of the weight is in hydrocarbons. So
Hmm.
uh,
Fascinating.
they're completely natural. So let's go on. Let's see if we can advance here. Um, so I should say that I've been involved in climate for a long time. For years, I've been a member of the Jason consulting
Yes.
group that does summer studies for the government. And this was a book that was published by this group in 1982. I was one of the co-authors here. And
Hmm.
it's the long-term impacts of atmospheric carbon dioxide levels. So this is an area I've been working on for almost 40 years. Next year it'll be
Yes.
40 years. And I've been working on this before. So let's see if we can advance this.
Now, is this available on that website to be printed out, Doctor?
It's hard to get that. You can track it down. There were not that many books published, but you can get them from the internet if you want to look.
Good.
It's way out of date, so I don't recommend it. And to my
Okay.
shame, I got the same along with my colleagues wrong overestimates of warming that everybody else did. But at least I was
Uh-huh.
able to learn from my mistakes, which not
Yes.
everyone can.
Which is what scientists do.
Yeah. So anyway, this is just to illustrate what I guess I'm most noted for, aside from being a thorn in the side of the climate fanatics. Uh, so
Fascinating.
this is the sodium guide star. That if you go to any big new telescope, this is I think in Maui, Hawaii,
Hmm.
and oh no, this is Kirtland Air Force Base. Yeah, but they all look the same. There's this beam of yellow light going up into the sky. And so this
Hmm.
was something I invented in the early days of Star Wars, the missile defense
Hmm.
effort, when we were trying to figure out any possible way to stop incoming missiles. And one of the ways was to try to shoot them down with a intense laser. But the trouble was,
Hmm.
if you aim the laser up high in the sky toward the incoming missile, the turbulence in the atmosphere would smear out the beam so much that you couldn't get enough energy onto the target to cause any damage. And astronomers knew how to correct for
Hmm.
this when they were looking at stars at night. You have the same problem with observing stars, but you needed a very bright star to measure the turbulence and then correct for it, by deforming the mirror. And
Fascinating.
so it was known you could correct if you had a bright star. And so my contribution was to point out that you could make an artificial star any time of day or night with this sodium laser beam here. By chance, I knew there was a layer of sodium 100 kilometers everywhere over the Earth, and that there were so many atoms there that you could shine a laser on them and make this artificial yellow star. So in fact, this did work. It was very secret for 10 years. And they built this observatory was built at my suggestion out in the desert out of Kirtland, Air Force Base in New Mexico. And they did a lot of the most important early work there on adaptive optics for astronomy and for missile defense and just for seeing in general into space. So anyway, I know a lot about the atmosphere, more about radiation transfer than most climate scientists do. So let's,
Doctor, can I ask you a question?
yeah,
Now,
sure.
the motivation behind your invention here was did that obviously it had to do with the SDI program and what Ronald Reagan was talking about in the 1980s, correct?
That's right. That's right. Yeah, and it was one of the first sort of advances in the laser field, you know, that made it look like it might be possible to use lasers to stop incoming missiles. It's still a hard, you know,
Would,
it's a hard slug because, you know, for example, if it's cloudy, this won't work. And as
right,
we'll discuss later, you know, half the time, you know, they're clouds. I'm looking out today and, you know, about a third of the sky is covered with nice white clouds. And that's pretty typical of the
right.
Earth. And that's very relevant to climate.
And what's
Okay, so
interesting, Doctor, what's interesting, Doctor, is that you played a part in winning the Cold War, because once the Russians, the communists, understood that we were trying to create this SDI program, that they basically spent themselves into oblivion to try to match our science, correct?
I think there's a lot of truth to that. Yeah. But we don't need the Russians to ruin our society. We can do it to ourselves.
Unfortunately, that's fact.
Yeah.
Great information.
Okay, so let's move on here. So here is the essence of the you know, climate crisis narrative. This is actually a slide from NASA. I think maybe Kevin Krinberg virtually made it, but the Earth is warmed by sunlight. I'm looking out my window now during this talk, and I can see the beautiful blue sky, the sun coming in, and it's pretty hot from the sun. And some of this sunlight is reflected by the sky, the blue light, you know, that we look up and see. A lot of that goes out into space and never is turned into heat. Some of it is reflected by clouds. I see a lot of clouds now looking up. This says on average 20%. That's about what it is today. And some of it is just bounced off the Earth's surface and never turns into heat. But roughly, you know, half of it gets absorbed by the land and turns into heat. You know, if you've ever had a garden, you know, you can put your hand into the soil at, you know, midday and it's nice and warm. That's what makes the plant grow, you know, and so that continues heating all day. And then at the same time, that heat is being removed by a number of mechanisms. The most important is that hot air rises up. So this is, it says conduction and rising air. And the other is radiation. So the Earth radiates up through the atmosphere, and some of the radiation gets all the way to space, and the atmosphere itself radiates the greenhouse gases and the clouds. So Earth is in balance between the heating from visible sunlight and the cooling back to space by invisible you know, thermal radiation, which is much longer wavelength, typically 20 times longer wavelengths than the short wavelengths coming in from the sun. And that radiation is affected by greenhouse gases, but it's not affected very much. And if you double greenhouse gases, it hardly makes a difference. And we'll look at the details of that. So details matter here. It's not enough to just sort of get a touchy feeling, you know, for what's going on. You really have to put in numbers. And when you put in numbers, there's nothing to worry about. Okay, so let's look at how heat is transferred. And worth remembering that there are three ways that heat is transferred. One is radiation. That's sort of at the center of the climate crisis debate. Radiation being the same kind of thermal radiation you get from the hot elements on an electrical range. Another very important one is convection. And if you have a pot of water, hot water at the bottom of the pot is rising to the top. And if it's boiling, it'll bubble up steam. And so that transports huge amounts of heat. That happens also in the air, both in the atmosphere and in the oceans. So there's major amounts of convection in these two major fluids, the oceans and the atmosphere. And finally, there's conduction. That's usually a very short range thing. You can feel the handle getting hot on this pot if you're careless, but that's not very important in climate. So conduction exists, but it's not a major player. The major players are convection of the atmosphere and radiation of the atmosphere. So let's see if we can get to another one. Now, we mentioned greenhouse gases already, so here is a useful plot of the various greenhouse gases and how much they attenuate radiation from the surface going to outer space, or vice versa, from outer space coming back down. So you can see that that water vapor is extremely potent. If you look at radiation trying to get from the surface out to space, all of it is absorbed here at these wavelengths. And so these are wavelengths in millionths of a meter. It's the jargon is microns, so wavelength in microns, a millionth of a meter. So water absorbs most of the thermal radiation. These are spectra of thermal radiation from the Earth that's trying to get out to space and cool the Earth. And there's a narrow window here through which radiation can get through, even if there's water vapor. Carbon dioxide also absorbs, but you can see it's not nearly as important as water vapor. And actually most of the absorption and the action of carbon dioxide overlaps water vapor, so they kind of compete with each other. Ozone here is important. Methane, we talked about the cows burping, nitrous oxide from farmers' fields, and finally the blue scattering of Rayleigh of the sky. That's almost irrelevant to thermal radiation, but it is important for the sun. So these are important facts to keep in mind. The sun, by the way, has much shorter wavelengths. You can see that wavelengths of the sun are typically 1 micron or less. So as I said, about 20 times shorter wavelengths than the wavelengths of the warm Earth trying to radiate to space. So let me try and advance.
Doctor,
yes.
Doctor, let me ask you a question now. Those who purport and support the idea of man-made or anthropogenic global warming, don't they point towards carbon monoxide and the machines, the exhaust, creating carbon monoxide that has no bearing or any effect, provides no factor in
carbon monoxide is a greenhouse gas, but there's so little of it that it really doesn't matter compared to carbon dioxide. You know, if you have a well-tuned, engine, internal combustion engine, you don't like to let it emit much carbon monoxide because there's heat content there that you haven't used. Carbon monoxide will burn. So you try to put in enough oxygen that everything is burned to carbon dioxide, but there's always some carbon monoxide coming out. And if you're not careful, you can kill yourself because it's very poisonous. That's why you should be careful about running your automobile engine, inside a garage, or running a space heater, with propane or kerosene inside your house. Lots and lots of people have poisoned themselves with carbon monoxide, but it's very different from carbon dioxide. I once had to testify to Congress, and a very nice congressman, when I was explaining that there was nothing to worry about carbon dioxide, it was actually good for life. He says, "How can you say that, Dr. Happer? Do you mean I can sit inside my garage and keep the car running and I have nothing to worry about?" I said, "No, Congressman, I'm talking about carbon dioxide, not carbon monoxide." They're different.
That's right. Very, very different.
Yeah, very, very different. That's right. Carbon dioxide doesn't last very long in the atmosphere because it's like methane. It's oxidized by the oxygen and the ozone and other stuff, the hydroxyls in the atmosphere. It's a good question.
And doctor, the thing is that most people think that the exhaust coming from these airplanes and from the cars, that is contributing to this anthropogenic global warming, and it's totally untrue. And we see we see manufacturers, government requiring regulations on manufacturers and the construction of an engine and so forth, and moving towards electric cars, and it's just all based on bad science, right?
Yeah, it's based on misunderstanding science, and in some cases bad
Right.
science, that's science for propaganda reasons, not for real reason.
Right.
Yeah.
Mhm.
So let's
Great. Very
talk a little
informative.
more about the physical facts if we can.
Great.
So I downloaded this half an hour ago. So this is looking down from a geosynchronous satellite that's pretty much over our heads, up 35
Mm.
miles or so. Uh, it's I'm sorry, 35,000 miles.
Yeah, I was
It's
gonna say that looks a lot further.
so this is actually not the visible Earth. I'll show you the visible Earth in a minute, but this is
Okay.
infrared radiation. And it's the Earth glowing in the dark. So this is radiation we can't see ourselves with our eyes, but say a
Mm.
rattlesnake, which senses infrared, he would be able to see this. And you can see here in New Jersey, we were
Amazing.
partly cloudy up here. You can just barely make out the outline. But another important thing I want you to notice is there are lots of clouds of various
Mm.
heights. So this white stuff is a very high cloud. And so it's white because this is, white means it's cold. And the darker it is, the hotter it is. So you can see it's quite hot here in eastern Brazil. But if you go a little north in Brazil, it's a little cooler because these are low clouds that are a little bit higher in altitude. So they don't radiate as much because they're a bit cooler. There are lots of low clouds
Mm-hmm.
over the South Pacific here. And along the
Mm-hmm.
equator, this is called the intertropical convergence zone. And this is where there's lots of upwelling air, driven by the sun. So the sun is walking across the equator now. We're almost at the fall equinox when the sun is over the equator, and
Mm-hmm.
it will soon cross the equator. That takes us to fall, and it takes
Mm-hmm.
the southern hemisphere to spring. And so in just
Mm-hmm.
about a week, the sun will go from north to south across here. Let me move to another one if possible. Let's see.
Certainly remarkable.
Um, well, I'm not, let's page up. I'm not sure. Uh, having a little trouble with my view graphs here. I'm
That's
not quite,
fine. That's
not
fine,
quite sure how to
Doctor.
navigate this. Previous,
Take
previous, this is not working. Yeah, okay.
you can go right in order,
Yeah,
Doctor, if you
okay,
like.
well,
Talk about the CO2 molecule.
yeah, okay, let's go to the CO2 molecule. Okay, so since I'm a physicist, I can't resist talking about the physics. And so the way the CO2 molecule contributes to greenhouse effects is that it has modes of vibration. I mentioned it's these three atoms stuck together, oxygen's on the end, a carbon in the middle. And these molecules can vibrate, and it's the vibrations that absorb and emit infrared radiation. In one of them, the carbon moves toward the oxygens, and the oxygens move in the other way. So this is called the asymmetric stretch mode. It's
Mm-hmm.
such a high frequency, it really doesn't interact with much thermal radiation, but it's what's used in CO2 meters. If you have a meter to measure CO2 in your house, it uses this frequency. The main frequency for the greenhouse effect is this bending mode where the carbon moves up and the oxygens move down. Very much like the way a xylophone bar vibrates, in a xylophone.
Mm-hmm.
And that is a potent absorber and emitter of thermal radiation. And I like to joke at 666, it's Satan's number, right, of waves per centimeter. Of course, it's just an accident. And finally, there's this symmetric mode, which because of the symmetry doesn't absorb or emit at all. And so has no direct relevance to the greenhouse effect. But there's a lot of very interesting physics that if that's your bag, you will find interesting. Not everybody likes that. So let's
Doctor, let me ask you a question.
yeah.
So the atmosphere is made up of approximately 80% carbon, correct?
80% nitrogen,
Yeah, nitrogen,
atmosphere,
that's right.
80%
All right, so
nitrogen, roughly 20%,
right.
oxygen. And then everything else is a trace. The most important third one is actually water vapor. There's typically
Mhm.
a few percent water, outside today, and water probably is 3 or 4% of the air close to ground level. Water condenses out
Mhm.
as you go up, so the atmosphere gets drier and drier as you go up to higher altitudes. There's practically no
Mhm.
water above 30,000 feet. Uh, so let's see. Let's look at the next one. Now let me say a little bit about carbon. And people demonize carbon. Carbon pollution. I
Mhm.
don't know what they're talking about. We're made of carbon. If you look at our own bodies, uh, we're
Mhm.
mostly oxygen, 65% by weight, but the next most abundant is carbon, and there's carbon all over our bodies.
Mhm.
Our proteins, the muscles are made of carbon. The fat in our body is made of carbon. Our DNA is full of carbon. Everything about
Mhm.
life is based on carbon. So how they've
Mhm.
managed to turn the molecule of life, the basis of life, the basis of organic chemistry, into a pollutant is beyond me. It just shows that, as I guess it was Barnum supposedly said, there's a sucker born every minute, and it's happening again.
It's truly remarkable. It's truly remarkable, doctor, that they consider carbon to be this pollutant, and you're making, and many other credible scientists from the very beginning that we've been observing and creating a scientific experiment understand this. How is it possible that in the modern day that they would try to make something out that is so beneficial and good as carbon CO2, make it out to be a pollutant? I mean, it really is remarkable.
Yeah, it is remarkable, and it's partly due to the low science illiteracy. Science is not very well taught, or maybe not very well learned, and so
No.
they're able to get away with this with credulous people. Each one of us, is a pretty potent carbon emitter. We emit about 2 pounds of CO2 every day, and
Hmm.
so if you multiply that by, what is it, 8 billion people, what is that,
Yeah.
16 billion pounds of CO2 a day just from people being alive. Some
Hmm.
of the crazier environmentalists, they say, well, 8 billion is too many. We've got to reduce the population to under 1 billion. And so then the question comes up, okay, there are 8 of us here, which 7 of us have to commit suicide so you environmentalists can be happy. It's really quite dangerous, I think. These people are dangerous fanatics, and they're
Yes.
not fanatics based on science. It's just
No.
pure fanaticism.
No
Okay, so
question. And it affects the thinking, and it affects the thinking of a lot of young people deciding, well, we have this terrible climate change issue. We don't even want to have children and bring them into this world. And it's all based on fallacy to think that way.
it is a fallacy, and it's shameful that they've been misled that way. I mean, I somewhere in the scriptures it says anyone who offends one of these little ones, has really
Mm,
committed a big sin, and
yes,
boy, nothing could be
very
truer than
true.
that. Yeah. So let's see, where is the carbon in our own bodies? I mentioned the hydrocarbons in our fat. And so
Hmm.
sometimes we have a little too much of that. But
Hmm.
protein, that's our muscles, and that's just full of carbon. Every black circle here is a carbon atom. And
Mm,
so
interesting.
DNA, RNA, we're loaded with it. We can't live without carbon. So,
Hmm.
so won't we fry for more CO2? The answer is absolutely not. Life is going to flourish from more CO2. So let me say a little more about the physics.
Mhm.
So it's very important that you understand the temperature structure of the atmosphere. I think we're all vaguely aware that if you go to the mountains in the summer, it gets cooler. And that's because the Earth's lower 10 kilometers or so, the temperature drops as you go up in altitude. And that continues to the height of about 10 or 11 kilometers in New Jersey. And that's about a little bit higher than the top of Mount Everest. If you go much higher than that, the cooling stops, and in fact, it starts to warm again, and the atmosphere continues to warm as you go up in altitude until about 40 or 50 kilometers. The stratus falls, and that's because of ultraviolet heating from the sun. There's ozone up here, the famous ozone layer that you alluded to earlier in this talk. And that absorption of ultraviolet heats the stratosphere. So most of our life, however, is down here below 10 kilometers, close to the Earth's surface. And there is this rapid cooling with altitude. It's why you want to have a summer cabin in the mountains to stay cool. So we'll have more to say about that later. But by the way, this is why greenhouse gases warm. You know, in the stratosphere where the temperature is going up, greenhouse gas is cool. So whether greenhouse gas is heat or cool depends on the temperature profile. Yeah, very few people understand that too. but you know, you could stop greenhouse gases if you got rid of this cooling here, this famous lapse rate. So it's a lot more complicated than John Kerry thinks. So here is sort of a God's eye view of the Earth, greatly simplified, but most sunlight comes in near the equator. You know, at our latitudes, the sun is coming in at a slant, so we don't get as much per surface area as they do at the equator, except if, you know, during midsummer, people are surprised to realize that the place that gets the most sunlight average sort of over 24 hours is the North Pole, you know, so it really counts. If the sun never sets, you get a lot of sunlight in a day. But of course, it's not as intense at any given time as it is at the equator. But the sunlight drives rising hot air at the equator, and this rising hot air, which makes lots of clouds, we saw a picture of it on the satellite a few minutes ago. Some of that hot air, when it reaches the stratosphere, goes north, some of it goes south. And as it's rising, it rains out all of the moisture. So the air that's coming north and coming south is extremely dry. And when it typically falls down at about 30 degrees north, these are called the horse latitudes by sailors. And it's the band of deserts. It's where the Southwest deserts are in Mexico and the United States. It's where the Sahara Desert is over here in Africa and Arabia. And there are similar deserts in the south. The Patagonian Desert and the Namibian Desert are 30 degrees south. So there, you can see the sort of this macroscopic effect of this circulation of air in the desert belts and the very moist air you get along the equator. So this is grossly exaggerated because the height, 10 kilometers, you can barely see. So compared to the radius of the Earth is, you know, like 6,000 kilometers. And so it's a very thin skin, but it's been exaggerated to make it a little clearer too. So here's the Earth again looking down. Here's the intertropical convergence zone. It's the Earth glowing in the dark. And the point I'd like to make here is that really what controls changes in Earth climate are clouds. Clouds are the 800-pound gorilla. This satellite image is covered with clouds, high cold clouds, the white clouds, low, cooler clouds down here. And, you know, clouds are very hard to understand. This is a picture of the cloud cover earlier this morning. You can see it's partly cloudy here over New Jersey. Here's Delaware and New Jersey. There's some high clouds offshore today, and a lot of cloudiness down on the Gulf Coast. And again, down here you see the intertropical convergence zone, but in the visible, this is reflected sunlight. So this is a little bit different. Wherever it's white, that means a lot of sunlight is being reflected. So clear regions like the oceans absorb most of the sunlight. It doesn't reflect very well, and the land doesn't reflect very well, but clouds are very good reflectors. So again, you see this huge layer of clouds over the South Pacific of South America, and over, in fact, most of the oceans. So these clouds keep the sun from heating the earth. So the tiniest change in clouds here outweighs huge changes in greenhouse gases. So clouds are the driver of climate. So that's an important message, one that's hidden from most people by the zealots. And it's because nobody really knows how to calculate anything from clouds. You can guess from the complexity of this that it would be hard to calculate. And it really is hard to calculate anything sensible. But here is a satellite observation of cloud-free radiation coming up from Earth. And so again, this is the frequency of the radiation, sort of the color of the radiation. So this would be, in analogy to visible radiation, this would be red radiation, blue radiation. And what I'm showing here is that CO2 does indeed suppress the radiation to space, but quite a bit less than the suppression by water vapor and the suppression by, just by water vapor. And if I included clouds, which I don't here, clouds would be even more important. But CO2 is a greenhouse gas. It's second to water vapor as a greenhouse gas. And the Earth is very different depending on where you look. This is Sahara, the Sahara Desert. So this is the infrared window we talked about earlier, where there's very few gases that absorb. And there you can see the temperature of the hot sand, 320 Kelvin. That's quite hot. That's over 100 degrees Fahrenheit. This is the Mediterranean. It's quite a bit cooler, because of the sea, but you still see CO2, you still see water vapor. And this is Antarctica. And here it's interesting, you can see that over Antarctica, CO2 is actually a cooling gas. So this is the CO2 effect over Antarctica, and it actually is increasing the radiation to space. So over the poles, CO2 cools. Over most of the rest of the Earth, CO2 is a warming gas. But again, very few people will tell you these complexities.
And so it's amazing, Doctor. It's amazing that the globe is so big. And there's so many different variations in geographical locations that how can the proponents of anthropogenic global warming possibly come to an accurate model, or come to clearly specifically understanding all these different variations in temperatures based on how large the globe is?
Well, the simple answer is they can't, and that's been demonstrated. If you look at how the model projections have worked, they've all predicted 2 or 3 times more warming that's been observed. And the newer models are even worse, so, the community seems unable to learn from their failings. It's really amazing. It's very different from any other branch of science that I'm familiar with, and I know a lot of them, but climate is bizarre, at least in the physical sciences. But let me say a little bit about this transparency, because this is the heart of the matter of why CO2 makes so little difference. So what I'm showing here is actually a calculation, but you can see it's very similar to the satellite observations I just showed you, which is real data.
Yes.
Observation is not somebody's calculation. So what I'm showing here
Mhm.
is the radiation that would be going to outer space from New Jersey in the summer on a typical day. And that's this black curve. And if there were no gases, the radiation would be this smooth blue curve here. And that blue curve was discovered by Max Planck in the early 1900s, 1905, 1906, around that time. And it was the
Mm.
birth of quantum mechanics. So people don't
Mm.
realize that quantum mechanics, it didn't come from particle accelerators, or radioactivity or things that we think about today. It came from studying heat radiation. So
Mm.
heat radiation has an
Fascinating.
old and honorable history in physics. And the key
Mhm.
player was Max Planck. He was a great
Mm.
man. He figured this stuff out. He refused. He
Brilliant.
stayed in Germany during World War II. He refused to abandon it. He refused to join the Nazis. His son was executed by the Nazis for being part of a plot against Hitler. And so Planck is really one of my heroes. And so
Mhm.
the blue is his curve. Now
Amazing.
now you can see there's a faint red curve here. That's what would happen to
Mhm.
the radiation going to space if you double CO2 from its current value today, 400, if you double it to 800. And
Parts per million.
8 parts per million. So this is parts per million. So this is a huge change. This is a 100% increase of radiation to space. But if you calculate what that does, it's about a 1% decrease, 1% decrease of the radiation to space from a 100% increase of CO2 in the atmosphere. So what the
Mhm.
alarmist community is struggling to do is to turn this very tiny change of radiation transfer into something that looks threatening to justify all
Mhm.
of the extreme measures that are, governments are trying to shove down the throats of people around the world.
Yes.
And, the ultimate
And
cause
New
is this
Jersey.
tiny difference between this black curve and this red curve here. So it's
Mhm.
absurd. This is
Yes.
the same thing with
Remarkable.
methane from the cows burping, right? Again, yeah, it's even smaller. You
Mhm.
can hardly tell the difference, and nobody's going to double
Mhm.
methane, but it's just a tiny effect. And to drive farmers out of business is, well, it's criminal. This should not happen.
Yes.
Farmers shouldn't
Right.
stand for it, and the rest of us shouldn't stand for it either.
Right.
The jagged curves, by the way, were not due to Planck, but to his contemporary Carl Schwarzschild. So I like to call the smooth curve here the Planck curve, and the jagged curve,
Mhm.
which is what actually is observed on Earth due to the greenhouse gases
Mhm.
in our atmosphere. Uh, that was Carl Schwarzschild. He was another German physicist. He died during World War I on the Russian front, not from a Russian bullet, but from a horrible autoimmune disease that he had. But he was
Mm.
a brilliant man. He was one of the first to write down an analytic solution to Einstein's general uh, theory of relativity to those
Brilliant.
equations. So he was a fantastic guy. And among the other things he did was he showed us how to calculate the effect of greenhouse gases.
Mhm.
And the answer is the effect is almost trivial. There's nothing to worry about. Well, let's see.
Mm.
I'm sorry to make this a physics lesson, but
Oh, no, it's great. It's great, great education. I'm sure everyone is appreciate watching it, and we're
okay,
learning. And that's the whole point of what our organization is all about.
yeah, good.
And of course, it has political consequences because of those who believe in alarm.
Yeah,
As you said, they want to put meat producers out of business. They want to change the way automobiles are made. And it's really interesting, Doctor. What is it that they want to do? I mean, what are they trying to do in thinking that they can control carbon dioxide levels? Do they really think that they really believe that they can change climate, which is impossible? correct?
Yeah, I mean, there's nothing we can do with carbon dioxide because it is so impotent, as you can see from this graph here. And quite aside from the scientific facts, is the only way you can reduce carbon dioxide really is to kill people. There is no other way to do it. You know, what they're demanding is absolutely devastating to the world economy and to human life. We can't run our society without fossil fuels, at least for now. You know, if somebody can think of a good way to make energy, I'm all for it. And I'm sure that will eventually happen if we don't kill off the human race first. But we'll figure out how to provide the energy eventually, even if we run out of fossil fuels. But that's not going to happen for a long, long time. And it's causing more harm, whatever. In fact, it's good for the earth.
Right, and we haven't even begun to discuss the importance of carbon dioxide in relation to vegetation and all things green and all things growing,
Well,
which is
let's see if we can do a little of that before we run out of time. So let me see here next. See if I can advance this. Well, CO2 is increasing. This is a record of CO2 levels in parts per million. We talked about 400 just a few minutes ago. And it's interesting, it's increasing in an up-down way. It increases most rapidly during the winter, but every spring when plants start growing, it goes down again. So this is spring, summer, CO2 has been sucked out of the air by plants. Winter comes, there's no plant growth, CO2 goes up, then it's sucked down again the next summer, next summer, next summer. But there is this overall trend. It's about 2 parts per million per year. There's some fluctuations. And so it's definitely going up. One thing
now, Doctor, let me,
yeah.
Can I interject? I'd like to ask you a question.
Yeah.
Now we know from history that the CO2 levels were much, much higher thousands of years ago. Yes, and yet there was no industrial revolution.
Yes, that's
there was
right.
no pollution being attributed to machines or factories. So how is it that the alarmists don't take that into consideration with their models?
Well, they simply ignore it. And but you're right. The geological record shows that CO2 levels have never been stable. In fact, you know, early on they were much higher than now. You know, it's a little hard to determine that because there was nobody measuring it back then. So you have to rely on geological proxies. And you would know better than most that there are a lot of problems with proxies. But you try to use several independent proxies. You know, for example, you can look at the number of holes in leaves, fossil leaves, and that will give you an idea of what the CO2 levels were. Or you can look at the carbon 12, carbon 13 isotope ratios, which depends on the amount of atmospheric CO2 and
carbon dating.
So that there's very little question that CO2, most of Earth's history has been much higher than now. And plants really would prefer growing in 2 or 3 times more CO2 than we have today. And greenhouse operators recognize this long, long ago. You know, a good commercial greenhouse will often double or triple the CO2 levels inside just because it's worth paying for the CO2. CO2 is not cheap. You have to pay for it. But it's worth buying it because you get better flowers, you get better fruits, you know, better produce from your greenhouse than without it. And, I was interested today to read that there's a crisis in food in Great Britain now because they don't have enough CO2, you know, for soda water and other things where you use carbon dioxide in the food processing industry. So it's really quite ironic, actually.
Yeah, it is.
So let's see. This is methane. Methane is also increasing, but it's a lot less systematic. Nobody really understands what's driving methane changes. And methane doesn't last very long. It's burnt up basically by hydroxyl radicals in the air, and in 10 years or so, it's all burnt. So methane is not a big deal, in spite of what they say. It's not, since I gave this talk for farmers, you know, I paid a lot of attention to methane. And now it's true that per added methane molecule, you cause about 30 times more warming than per added CO2 molecule. But what the other side never tells you is that CO2 increases 300 times faster than methane. So, you know, it's not just the per molecule amount, but it's how many molecules are being added. So it's profoundly deceptive. You know, they say methane is 30 times worse than CO2. It's not 30 times worth. It's only in 1/10 as effective as CO2 and the warming that it's caused, because there's 300 times more CO2 coming out than methane coming out. That's just another example of the dishonesty of the message, the narrative. Another important thing to remember is that if you put enough molecules into the air, they get in each other's way. So the per molecule forcings, the effect on radiation per molecule of CO2 today is a very, very tiny fraction of what it would have started with when there was no CO2 at all. So it's been suppressed by almost 10,000 times, because the CO2 molecules have absorbed almost all of the radiation they easily can. So we say the CO2 bands are saturated. That's why the CO2, as I showed you before, you can double CO2 and it hardly makes a difference to the radiation to space. It's heavily, heavily saturated. Nobody can deny that. They like to hide that, but they won't honestly deny it. Methane is also somewhat saturated, but only by a factor of 10, not by a factor of, 10,000, the way CO2 is. So it's sort of a tidbit, but it's true.
Right.
So again, basically for
CO2 in the
farmers
atmosphere.
for whom this talk was prepared, the effects of CO2 are only about 1/10 of the effect of carbon dioxide in terms of suppressing radiation to space. And now the next step is, how does that change the temperature? Well, it presumably is proportional to this, and the temperature changes are certainly very small, and they're 10 times smaller for methane than they are for CO2. So how do models work or not work? This is a chart from John Christie at the University of Alabama, Huntsville. John Christie and Roy Spencer invented the satellite monitoring of temperature, and they really should have gotten a Nobel Prize for that. It's been so important. But these are satellite measurements of the temperature of the atmosphere, mid-troposphere, in green. And blue is just to show that balloons can also measure temperature directly. You put up thousands of balloons every day for weather forecasting. They measure essentially the same warming. So both satellites and balloons are measuring this tiny warming per decade. It's like a 1/10 of a degree centigrade per decade. The red is the predictions of the alarmist models. And by the way, the predictions are getting more alarmist. They're not getting better. And so you can see that we're basing public policy on this red curve. The red curve isn't even close to what's observed. And
Doctor,
how can you do that?
Doctor, let's tell the audience what the IPCC is.
IPCC is the International Panel on Climate Change or something. I may have it wrong, but it's a UN body that was set up by environmental extremists back around 1990. I don't remember the exact year. It was when I was in Washington, actually, and I was forced to fund some of it by, my boss, the president. And Anyway, it's a UN group now, and its job is to spread alarmism. That's why it exists, and so they're doing their best to do their job. But it's not like any organization I ever saw. It's more like the Comintern, I think, under the Soviet Union than it is like a scientific organization.
Certainly.
And anyway, this is IPCC predictions.
Model.
Okay, how do they work? Here's quantitatively how they work. This is from Nature, which is an alarmist journal, so it has to be right. This was, by the way, I mentioned I was a little ashamed of my early prediction in 1982. I predicted a warming of about 0.2 degree per decade back then. We didn't know as much back then. But that was kind of the middle of all the IPCC models. They're all predicting something like that. So it was pretty good average. So these black bars here are model predictions of warming per decade. So left to right, there's 2 degrees warming per decade, 4 degrees warming per decade. The red's what's observed. And you can see that the predictions aren't even close to what's observed. The warming has been much less than observed. And this is over, let's see, this is over a 10-year span during the pause. And this is over a 20-year span, 1993 to 2012. Anyway, both of them, the message is the same, that the predictions, these gray bars, are much, much higher than the observations of warming. And let me say also, this red observation, nobody knows how much of that is due to carbon dioxide and how much of it is just natural warming, because we're coming out of a little ice age and have been for the last 200 years. And so there's been a very natural warming from the extreme cold of the 1700s, 1600s, 1700s, early 1800s, to more normal temperatures today. And so some of this red warming is probably due to the little ice age recovery. And when you look at the facts, the hard facts, there's no reason to believe that there's a climate crisis or a climate alarmism. So let's talk about agriculture. So when I talk to my academics, of course, nobody knows what they've not seen on a computer screen. So, when I ask them, what is this, to my well-educated friends, they say, well, is it marijuana?
Soybean.
Yeah.
Soybeans.
Soybeans, that's right. Soybeans. Normal people know it's soybeans, but not academics. At least not most of them.
That's amazing. We have a lot of them in South Jersey.
Good. It's good stuff. Makes a lot of protein.
Yes, it does.
This is what you mentioned earlier, JR. This is estimates of past levels of CO2 from the proxies, geological proxies. And so what this is the ratio of what you infer from proxy data to what it is today. And so going back in time, almost all of the time since the Cambrian here, where this begins, Phanerozoic, CO2 levels have been 5 times, 10 times, even 20 times higher than they are now. And life flourished. The coal swamps were, many of them laid down here in the Carboniferous 400 million years ago, when CO2 levels were 10 times what they are today. The only time it's been as low as now was this was the Permian period, when there were mass extinctions. Whether that was due to CO2, I'm not sure, probably not, but it was low then. That's the only time it's been comparable to today. So life has evolved in much higher CO2 levels, and it flourishes in much higher CO2 levels than we have today. This is the effect. This is Sherwood Idso, author Craig Idso, who's still active, and these are experiments Sherwood did back in the 70s and 80s on the growth
Mhm.
of a Mediterranean pine in
Hmm.
what was then ambient CO2, 385 back then, and
Mhm.
more CO2, more CO2, more CO2. These are all different trees, but growing in different amounts
Mhm.
of CO2. And you can see
Mhm.
the enormous acceleration of growth that you get if you put CO2 levels up to more nearly the levels that have characterized geological history. Plants really
Mhm.
love more CO2. So let's see if I can, uh, what happened here? I have, let me try to get back here. Okay, a blunder, but I will recover.
It's okay, doctor,
Yeah,
take your time.
yeah.
It's it's
Here it is.
remarkable that as we discuss these issues, we're learning that carbon dioxide, CO2, is something good. It's a good element,
Yeah,
as
it really
opposed
is
to the
good.
alarmists saying that it's a pollutant, which is ridiculous. And
Yeah,
also the fact that the CO2 levels have been much higher throughout history, and yet there was no industrial revolution at
yeah,
that time, or
exactly.
no burning of fossil fuel. So there's no correlation can be made between CO2 levels and the industrial revolution and machines emitting exhausts.
Yeah. Well, I personally think that most of the increase of CO2 is from burning fossil fuels, but I welcome it. I think it's a wonderful thing that CO2 is increasing, and you can see that
Mm-hmm.
all over the earth is getting greener. But here's another example of how plants are affected by CO2. This is a laboratory experiment with this particular weed. You probably know it. It's velvet leaf. It's a weed in my backyard garden. But
Mm-hmm.
weeds and everything else grows better as you add more CO2. So there
Mm-hmm.
are hundreds and hundreds of experiments that show the benefits of more CO2. And
Mm-hmm.
these are quantitative studies done by Sherwood Itzo that I mentioned, uh,
Mm-hmm.
and Craig Itzo and his brother, Keith. But these are how plants increase their response as you add CO2. You add 300 parts per million, everything grows better. Vegetables, potatoes, turnips, soybeans, fruits, C4 cereals, that's corn,
Mm-hmm.
sorghum. C3 cereals, that's wheat, rice, barley, oats. CAM is interesting. We probably don't have time to go into all of this, but CAM, C3, and C4 refer to three different types of photosynthesis. The vast
Mm-hmm.
majority of plants use C3. C3 is wheat,
Mm-hmm.
soybeans, cotton. But there are important C4 crop plants. Corn and sugarcane are the most important.
Mm-hmm.
And CAM is sort of a exotic outlier. It's plants like cactus, and
Mm.
the only plant I know of that we actually use is pineapple, is a CAM plant.
Hmm. How
But
about that?
I can't think of any others. But
Mm-hmm.
anyway, if we have time, we perhaps will say more about that. I don't think we will. Well, okay, why does CO2 help? There are two main reasons.
Mm-hmm.
Plants need less water if there's more CO2. The first thing that happens if you grow plants in more CO2 is they grow leaves that have fewer holes in them, fewer stomata. So there's
Mm-hmm.
less loss of water through respiration, transpiration, if there's more
Mm-hmm.
CO2. The plant doesn't need as many holes in the leaf to get CO2 if there's more CO2 in the air. So the plant is not
Mm-hmm.
dumb. It simply grows more efficient leaves.
Mm-hmm.
And the second is a lot more subtle and interesting scientifically, but there's the the key enzyme for photosynthesis is called rubisco, and it has a design flaw.
Mm-hmm.
When Rubisco was invented, there was no oxygen in the air. And so this key enzyme, Rubisco, is the most abundant protein in the world by far. It's the, if you were to add up proteins, it's an enzyme that all green plants have, but it's poisoned by oxygen. And so plants are full of antioxidants to protect this photosynthetic enzyme Rubisco from oxygen. And if you have more CO2, then there's less of this toxic oxygen problem. Here you can see the problem. C3 plants, all trees, by the way, are C3 plants. So here's an elm leaf. It has this hole, and into this hole, CO2 molecules diffuse. They bounce around in the other air, and they get in, and they're captured by the Rubisco. This is not a very good slide, but it says Rubisco, and with the aid of sunlight, the energy from sunlight, it combines the CO2 and water to make sugar. But for every CO2 molecule that diffuses into this leaf, typically 100 water molecules diffuse out, along with the waste product, oxygen. You know, when you make sugar, you've got some oxygen left over, so that is dumped into the air. That's our source of oxygen, photosynthesis. C4 plants
essential to
are
life.
like corn.
The oxygen is essential to our lives.
It's
the
essential to our
plants
lives.
producing.
Absolutely. Yeah, absolutely. But it's poisonous to photosynthesis. And it's poisonous also to, nitrogen fixation. That's why legumes like soybeans, the nitrogen fixing bacteria are isolated in root nodules. If you've ever dug up a soybean root, which is easy to do in New Jersey, it's got these big nodules on the roots. They're almost as big as a marble, you know, and you can, if anybody's listening, be kind to your neighboring farmer, but he won't mind if you dig up a root or two and cut open the nodule. It's blood red, you know, and it's blood red because of pumping oxygen out with hemoglobin. So,
fascinating.
You know, one man's benefit, oxygen is our benefit, is another man's poison. So it's poison to photosynthesis, and it's poison to nitrogen fixation. So anyway, the C4 plant copes with that by isolating the Rubisco in an oxygen impermeable fiber bundle here. And so that's corn and that's sugarcane, and they've evolved to cope with low levels of CO2 and high levels of oxygen. They're important, but most plants use this old-fashioned simple C3 because this costs you something. You have to have a lot more biological machinery in the plant, and it doesn't always pay, but it does pay in hot areas, and it pays when there's not very much CO2, which is what's the situation now. So CO2 is a benefit. Here's the Rubisco protein, the enzyme, a really messy, big, floppy, complicated thing with lots and lots of amino acids. And it's supposed to take carbon dioxide, combine it with water and make sugar. It doesn't show the water here, but water is being used. The whole thing is floating in water. But when it can't find a carbon dioxide, it instead takes an oxygen, and it turns the oxygen into nasty things like hydrogen peroxide. You know, you wouldn't want to drink hydrogen peroxide, and the plant doesn't like to make hydrogen peroxide, but it does by mistake because of this flaw in the design of Rubisco. So that's been a problem with photosynthesis from the beginning, once oxygen levels got high in the atmosphere. That is ameliorated as you add more CO2. You're less likely to make a mistake and pick an oxygen if there's plenty of CO2 available. So that's the second benefit, that is it gets rid of photorespiration. It suppresses photorespiration, which is a harmful thing for plants. Here you can see the greening of the Earth. This is a satellite picture of the greening. And so you see the greening is most intense in dry parts of the Earth. This is the Sahel, the southern Sahara, Western India, Western Australia, Western arid parts of the United States and Mexico.
Hmm.
And that's because, as I said, more CO2 lets plants cope with less water. They don't need as many holes in their leaves, so they grow better. And so this has been observed now for many, many years, and you can see the earth steadily getting greener and greener because of CO2 photosynthesis. By the way, I've tried to put references to the literature. You don't have to take my word. If you'd like to, you can look at the original literature. There's not much dispute about this. What I've done with my
And it continues to green, and it continues to green, Doctor, since 2010.
Yeah. Let's see if I can get back here. Well,
truly remarkable science. I hope our audience, I'm sure they're appreciating it. And
I hope so.
we hope the audience,
you can see I'm not
hope that the audience,
not a very good
hope that the-
navigator on here.
no,
Okay,
we
well,
appreciate the time and the presentation.
Open. I don't know what's happened
I'm
to
sure,
this.
sure the audience has gotten a lot of good information that they've never known before.
Yeah,
especially when it comes
I
to the
hope so,
benefits
'cause
of
I've lost
CO2.
control. Lost control of
Have
the
you?
screen here. Let me try and get out of this and redo it.
Not a problem.
Yeah. So share screen.
Yeah, there you go. You're
I
still
hope.
able to maneuver, Doctor.
I'm
You're
doing my
able to
best
get.
here. There's something not quite right.
All right, take your time. But what we want to, the audience needs to know, and especially our citizens who vote, is that a lot of these, the motivation behind a lot of these regulations on energy and the proliferation of renewables has a lot to do with the politics. And what we would talk about is cronyism, capital cronyism. And we know, and we're going to show it later on when the doctor's done, the amount of money that is spent in the state of New Jersey in subsidizing renewables like wind and solar is at the tune of now $600 million a year that the government is using to subsidize wind and solar. And these abnormalities are created, these market or economic abnormalities are created by the government interfering in the natural process of the free market. And as opposed to letting the free market manage itself, if you will, letting those who are creating the energy, like the nuclear industry, and even some of the fossil fuels, but especially nuclear energy, they're hurt because of the subsidies given the wind and solar, and the wind and solar is making a fraction of the power that our nuclear industries are making, and all because the government is intervening in subsidies. Whereas letting the free market, ingenuity, invention, let those who are coming up with these great ideas and inventions, let them make the money, as opposed to the government dictating free market activity through wage or price controls or subsidizing companies that don't produce as well as others.
Yeah, I completely agree, JR. And in fact, this is my last summary slide from this talk. So first point is climate models don't work. We're basing policy on models that don't work.
Yes.
Much too much warming compared to what's been observed. And they're getting worse. They're not getting better. Second point is that greenhouse gases actually make almost no difference. The climate is going to change as it always had without any changes of CO2, methane, or nitrous oxide. The greenhouse gases do cause very tiny effects, but they're not enough to matter. And the beneficial effects far outweigh any negative effects. I don't know of any real negative effects from more CO2. So no one is going to stop climate change. And so why cause all of this pain? And it's terrible. I'd like to refer to it as the inverse Robin Hood policy. You know, you rob from the poor to
Mhm.
give to the rich.
Mhm.
A point, the third very important point is CO2 is not a pollutant. Why do they keep calling
Mhm.
CO2 a pollutant? Each of us
Right.
exhales 2 pounds of CO2 a day. Are we polluters, you know,
Are
just
we
because we're
polluted?
breathing?
We're factories.
Yeah, yeah. More CO2 will benefit humanity because of its very beneficial effects on agriculture and forestry. The experiment has already been done many times in the past. Earth has always flourished with more CO2. And finally, you know, it's really immoral to deprive the world of fossil fuels or of modern agriculture, you know, which are demands of the CO2 climate change fanatics. You know,
Mhm.
it doesn't make any sense. It doesn't help anything, and it causes enormous harm. Uh, and yeah, I completely agree about nuclear too. Nuclear is a fine source of energy, but
Essential.
this was a talk for farmers, and few of
Well,
them have a nuclear plant.
that's commiserate with what happens in South Jersey
Yeah,
and all of the agricultural business. We are the reason it's called the Garden State
yeah,
down here in South Jersey. So I'm sure that the talk, and
right.
I'm sure some of the farmers that have watched this
Yeah.
can be encouraged about the benefits of CO2.
Well, the world owes its life to farmers. You know, if it weren't for farmers, that would be the end of life, at least human life.
That's right.
So God bless the
That's right. There's
farmers.
so that's right. And of course, as constitutional Republicans defending and advocating for the middle class, the farmers, our farmers make up
Yeah,
that middle class. And they work very hard and they have a tough job because they're dealing with climate, the natural processes of climate, too much rain, too much heat, too much cold. And they have no control over these things.
that's right.
And it's very important to realize, you know, they have a tough battle. They have to irrigate when there's not enough water. The worst thing that can happen is when they get too much water and the water just sits. You can always apply water, but you can't take the water away. So it's a very difficult occupation. And doctor, I wanted to talk to you before we wrap up about 97% of so-called climate science believes in the alarmist view, and they use the word incontrovertible. And from what we're seeing today in the presentation that you're so kind to give us, how is it possible that they can use the word incontrovertible if they are not motivated by circumstances that may benefit themselves?
Well, I mean, yeah, you see the 97% figure bandied around, or 99%, or 99.99%. It's all a myth. It's not true. You know, various people have deconstructed where those percentages came from. You know, for example, one I recently saw was one of these surveys to get 97% was they uh, sent out a request to, I guess they looked at abstracts with a computer that of papers that had something to do with climate, and they looked for the number. I think they found, I don't remember how many, but many thousands, and about 30% of them said, well, there may be a danger from climate change, and 70% did not. And so then they took the 30% and they double checked with them, and sure enough, you know, 97% of the 30% said, yeah, we stand by what we put down. So that's where the 97% comes from. It actually was 30%, right?
Mhm.
So it's that kind of stuff. You know, I probably garbled it a little bit, but it doesn't, it's not true. And most people who pontificate about this, many of my academic colleagues whom I like very much pontificate about it, but they don't know the first thing about climate. You know, the thing about being an academic is you easily get a swollen head because, you know, you deal with a lot of C students, and after a while you think, gee, I must be brilliant. And So you opine on everything, whether you know anything about it or not. And
Mhm.
so academics are particularly bad that way. But I don't know, the motives, there are many motives that keep this frenzy going. You know, the purer ones are honest, decent people who have been brainwashed,
Mhm.
and they really
Mm.
think there is a danger. They really think there is a climate crisis because they don't have the scientific background or sophistication to realize they're being lied to. You know, that has
Mhm.
always been a way that, you know, totalitarian societies get going. You know, Plato wrote about it, you know, he called it the noble lie, you know, and so
Mm.
a part of this is the noble
True.
lie. Uh, and then less noble motives involve my community. It's been a wonderful source of funding for research in universities and overhead in universities.
Mm.
You can build buildings and support, you know, administrators and deans, you know, with research funds for climate. And
Mhm.
so that's one reason that you see so much support from academia. And I hasten to add that there are academics who are doing an honest job, really doing important, honest research on climate related stuff. But it is definitely distorted by the funding requirements to
And
support the
some of those
narrative.
men, some of
Man,
those scientists, so some of those scientists you referred to, of course, was your good friend Freeman Dyson.
yeah,
Um,
Freeman,
Also,
I miss, he was my neighbor and colleague here at Princeton for many years and tragically died last year by an accident. You know, it didn't need to happen.
mhm,
But
right.
his view
That-
was similar to mine. He, you know, one of the last things he told me a few weeks before this tragic death was that, Will, I finally decided that we academics are doing more harm than good. He says, I've resisted that for a long time. But that was sort of his
uh-huh,
last words to me. It's ironic in many ways. Uh, but he was an
right.
honest guy. You know, he
Yeah.
all things as he saw
And
them. You know, and,
right. People can see Dr. Dyson on YouTube with some interviews he gave right up until he was 93, 94 years old.
yeah,
And also another name, doctor, is Richard Lindzen.
yeah. Well, Richard Lydson, another hero of mine. He, I think, was at the time the youngest person ever elected to the Academy of Sciences. I don't remember his age, but it was unseemly young. You know, I was elected
Mhm,
at a much older age, like most other people.
mhm,
And but anyway, he had the courage, since he was an atmospheric physicist and a very good one, you know, on the dynamics of the atmosphere, atmospheric tides, you know, the convection currents that I showed you on the slide a little bit earlier, taking air from the equator to the host latitudes. Dick did a lot of the key work in that area, but he refused to go along with all of the alarmism, and he was, I think, hurt more than most because he at one time was in a science that was real science. People were trying to understand the climate, and all of a sudden, boatloads of money started pouring into uh, atmospheric science, you know, to show that there's a threat to the climate from more from more greenhouse gases, and so you could get all the
mhm,
money you liked if you were willing to support that meme, or at least not to oppose it. And so
mhm,
Dick was unwilling to keep quiet, and so he was a very distinguished, still is a very distinguished atmospheric physicist at MIT. He's emeritus professor there, just like I'm emeritus here at
mhm,
Princeton. And you know,
mhm,
it's interesting. so many of us who speak out are emeritus, and the reason for that is that you can lose your career if you're a young person and express any doubts about the climate narrative. You know, if you're in the sciences, that's it's like the Ibsen's play, An Enemy of the People. You know that you're affecting everyone's income. You know, you can't do that. And so,
It's a great
so
point.
I think there are young people who know that this is nonsense, but they're not going to speak up until they reach retirement age. And that's a very sad and dangerous situation. It was
Yes,
like
it
this in
is.
the Soviet Union under Lysenko, you know, when the political, the politician said, you know, it's Manchurian biology and it's Lysenko and there's no such thing as genes and genes are a capitalist plot, you know, and
Yeah,
it was all, of course, nonsense, but it was
it's the
very real.
genetic
You know, you got
code
fired if you
are
did
made
teach
of.
about genes, and if you were unlucky, you
Mhm.
were condemned to death. You know, so fanatics are
Right,
bad people. You know,
right.
on any
And we're
topic.
not talking, and Doctor isn't talking about Levi's or Strauss genes. He's talking about the genes that make up our composition biologically, which of course the communists were saying were inherently capitalist, the
Yeah,
total, all propaganda based. But Doctor, a couple other gentlemen, you're familiar with Roy Warren Spencer, Dr. Spencer, Nassau researches. He's another contrarian, if you will. Are you familiar with him at
I
all?
don't know him. Yeah, I'd like to, but I don't. Uh-huh.
Yeah, he has a very good, he actually has a little printable guide called A Guide to Understanding Global Temperature Data. And of course, he is in agreement with you, and that's a source that people can look to. I also believe that there is a Canadian-based doctor, I believe his name is Richard Moore. I believe he is another contrarian that people can reach out to.
Patrick Moore, maybe you're thinking.
Patrick Moore, yes,
Yeah.
Patrick Moore.
Well,
I'm sorry.
Patrick, I do know very well. He's a good friend. Another one of my heroes. He was actually a founder of Greenpeace in Canada, and that was when Greenpeace started. As many young things, it was a good organization. You know, it was working on
Hmm.
important and worthwhile things.
Hmm.
Stopping atmospheric testing, for example. And
Hmm.
Patrick helped to get it started. But they solved many problems. They stopped atmospheric testing, and that was a good thing.
Hmm.
And so they, however, been used to getting all this income, to solve problems. So they had to invent new problems to solve, and they got less and less plausible as needing solving. And so Patrick Moore finally quit when they decided to declare war on chlorine. They had declared that chlorine was a demon molecule, and chlorine has saved more lives than practically anything you can think of from chlorinated water. People don't,
Hmm.
kids don't die of typhoid fever at the age of 3 anymore, but they used to. Used to be when you bought a cemetery plot, you'd get 1.5 graves. You want one for you, one for your wife, and at least 2 for children who died, before the age of 6, from waterborne disease. And that's gone thanks to chlorine. And so,
Hmm.
but Patrick Moore is really a real hero, and
And
I
also a
recommend
gentleman who
reading
you're
anything
familiar.
he's written.
Yes, I hope to contact him and have him join us for conversation sometime. And also a gentleman who wrote a book that I think is probably the most important book that people can read today concerning this alarmist globalist movement. And that was a history of climate change. The book I brought to you last week, and the gentleman who wrote the book, you said you knew. His name is Rupert Duval or Duval. I don't have the book.
Darwall, yeah, Rupert
Darval,
Darwall. Yeah,
yes.
he's
Rupert Darval.
he's an Englishman, and he's not a scientist, but he's a very good historian,
Yes.
economist.
And a great book.
Yeah,
Highly recommended book. The
yeah,
Age of Global Warming, it's called.
yeah.
And I also believe he spoke at Hillsdale College as you did as well.
It's quite possible, yeah. I would invite him if I were on the program committee. Yeah.
Well, absolutely. And be rest assured, Doctor, you're on the New Jersey Constitutional Republicans Committee, and we consider you our resident physicist. So I hope
Well,
you'll.
I'm not much of a politician, but I'm pretty good with differential equations and instruments.
Well, you're an educator, and it's such a blessing to all of us that you're continuing to educate, even though you're officially retired. You haven't retired. You're still educating. You're still promoting truth through science, and we really appreciate all the work you did. And before we wrap up, I just want you to give us a little bit of background and what your involvement is with a very important organization called the Academic Freedom Alliance. Tell the audience a little bit about that.
Well, this is a Princeton University organization that was mostly due to the hard work of my colleague and friend Robbie George and in the politics department. But, you know, there have been so many pressures on academics from the woke movement that people are afraid to say anything, you know, and you can say the most outrageous nonsense as long as it fits with the woke narrative.
Agenda.
And if you oppose it in any way, you're crucified. That happened to another one of my colleagues here, Joshua Katz, a very fine classics scholar at Princeton. So partly in response to his experience, Robbie George put together this organization, and it will defend academics against attacks on their, you know, freedom of speech, their academic freedom,
Yes,
especially from administrations. You know, one of the most offensive things about this attack on Joshua Katz was that, you know, the president of the university piled on. And after hearing from the Academic Freedom Alliance, which is relatively well lawyered, I would say, the administration backed down. And so I think it's terrible that things have come to this, but
yes,
I think that this type of organization is very important. It's the Academic Freedom Alliance will help other professors, not just at Princeton. It's been working with a number of professors at other universities over the past year, and very effectively, I think, and has had a number of wins.
That's great news, and it's an organization we help promote and let people know, and other educators to get involved, and students to get involved with that. Now, as we wrap up, Doctor, I want to say that in my estimation, a lot what motivates the alarmist is the fact that a lot of it has to do with the elimination of religious thought, of believing in a sovereign God who is in control of all the universe, who spoke the universe into being. And they think that, you know, man, it reminds me of the construction of the Tower of Babel, if you will. Of course, we know what the end result of that was. God confused all of the builders of that temple. Of course, it was an example of a concentration of power, which we see inherently is in the nature of man, and wanting to concentrate power either in a man or a oligarchy or group or a politburo, if you will. And how important it is that we realize that, yes, God is still in control. God is still sovereign. And we talked about last week when I had the pleasure of being with you, Psalm 19, which is one of your favorite Psalms, saying that the heavens declare the glory of God, and the firmament showeth forth his handiwork. Day unto day uttereth speech, and night unto night showeth knowledge. And that is what we're observing. That's what you observe as a physicist, all of that knowledge, all of that creation. And I think we really have to remember that the alarmist movement and a lot of this is based upon secular religion, based upon or humanism, if you will, and that man is the ultimate captain of his destiny, whereas we know that God is in juxtaposition.
Well, we have to hope that the Almighty is merciful, because he's got a lot to be merciful for.
That's very true. Well, Doctor, I want to thank you so much again for this extraordinary conversation. And I hope that people will like and share and discuss it with their friends and their family, the information that Dr. Happer was so graciously presented for us. And I hope that you will come back again, Doctor, soon, and we'll talk some more as we move along. But I genuinely want to thank you so much for joining me today.
Thank you. I'm going to say goodbye.
Very good. Thank you. Thank you, Dr. Happer. And I would
Bye-bye.
like to
Bye-bye.
thank you, Dr. Happer, for your time. And I'd like to say, as we end the program, as we end each one of our programs with the words of Lincoln, and he said that all this is not the result of an accident. It has a philosophical cause. Without the Constitution and the Union, we could not have attained the result. And that, but even these are not the primary cause of our great prosperity. There is something in back of these entwining itself closely about the human heart. That something is the principle of liberty to all. The principle that clears the path for all, gives hope to all, and by consequence, enterprise and industry to all. Thank you very much. And we will see you again next week for another New Jersey Constitutional Republicans virtual conversation. Good day.